Hello, boys and girls. Welcome back. We're back on Brilliant.org, and I'm Griffin, and let's do some basic mathematics warm-ups. If you're new to this channel, I want the main goal is to show you my thought process and help you be a better problem solver. So let's get started. Let's pull out our writing utensil and let's get going. So what's the question? Can we use each of the shapes on the left exactly once to make the shape on the right without any cutting? Alright, so here we have 4 circles with diameter of 1 and 1 circle with diameter 2. So if you're new to math, new to the lingo here, you might be curious, well, what is diameter? Well, diameter is simply the distance across. Here, let me use a easier to see color. The diameter of a circle is the distance across the circle whenever you pass through the center. So if here's the center, the diameter is the total distance across. And so this diameter of this circle is 2. And then you also might hear about the word radius that gets thrown around. Radius is half the diameter. Okay, so if the diameter is the distance all the way across the circle through the center, the radius would just be what? The radius would just be going from the edge to the center of the circle. And for this example, as the diameter is 2, the radius would just be 1. Alright, so what do we have? We have 4 circles with diameter 1, and we want to make 1 circle with diameter 2. Is this possible? Well, trial and error is always a great way to try and check. Well, what if, if I pull out my circle tool and start drawing 4 circles right next to each other, it quickly becomes apparent that no, you can't make a circle out of other smaller circles. It's just not possible. So this answer is going to be no. Alright, we got a streak going and everything. Clear our board, let's keep going. Can we use each of the shapes on the... So same question, new shapes. What do we have? We have a triangle with sides 9, 12, and 15, and a triangle with sides 5, 12, and 13. Can we make this triangle with sides 13, 14, and 15? Well, I would say the key here is the common side of 12. And which side is 12 going to be for each of these triangles? And why is there not a 12 over here? This is something that is kind of concerning to me. What could we do? Oh, well, what if this side from here to here must be the 12? It's the second longest side. The hypotenuse, the diagonal, is always the longest side of the triangle, so this will be the 13. This must be the 12, and this must be the 5. And then so for this triangle, the hypotenuse must be 15. The shortest side will be 9, and then the medium side is 12. So if we kind of flip and turn this triangle and line it up over here, what would we get? Well, let's kind of draw a little line tool. So this will be a distance of 5, right? So 9 plus 5 is 14. So we do have a 14 here, so that is good. We have our 12 for our height, and then we need to have this diagonal here. Let me use the line tool, make it as clear as possible. And what would this length be? This length must be the 13. So if we put this triangle over here, this is kind of what it would make. And would the lengths measure up? Well, this would be 13, 14, and 15. So yes, it does work out. It does work out. Excellent. And so we're going to say yes for this answer. Awesome. Clear our board. So here we have one regular hexagon and 3 equilateral triangles. So a regular hexagon that just means each of its sides are the same. So all of these sides are equal, and then equilateral triangle means the same thing. All these triangle sides are equal, and also the angles are also equal. These angles would be 60 degrees, as a triangle's interior angles all add up to 180, and there's 3 angles, so if you divide by 3 you get 60, so each of these angles would be 60 degrees. I don't think that's necessarily important for this problem, but it is something I would like to point out to you guys. So we're looking at this shape, this picture, and what can we do? Let's change colors. Let's go to this nice mossy green. How can we make an equilateral triangle? Well, I'm kind of imagining, what if we move this triangle here, one on top, and then one over on this side? What would we get? Well, we would get something maybe that would look a little bit like this. And, this looks pretty good. We would just move our triangles. It looks like our picture over here. The only last thing we need to check is this set says over here that each side length is 3. So let's double check that these side lengths are 3. It says our regular hexagon has a side length of 1, and our equilateral triangles also have a side length of 1. So this is 1, this is 1, and this is 1. So yes, it does have a total of 3. And if you go all the way around, it proves to be true for all sides. So this answer is yes. Awesome. Let's look at this problem. 2 squares of side length 1 make 1 square of side length square root 2. So is it possible to do this? This is pretty curious. Again, you might be wondering, where is this root 2 coming from? Especially, this is basic mathematics warm-up. If you're not familiar, there is this really basic theorem called Pythagorean's theorem, a squared plus b squared equals c squared. And what this is used for commonly is to find the hypotenuse or the diagonal of a triangle. So if we have a triangle, this side would be A, this side is B, and then this third side, the hypotenuse, is C. And if we have a triangle where each of these sides are 1, and if we plug it into the Pythagorean theorem, we're going to get 1 squared plus 1 squared equals 2 equals c squared. So c by itself equals square root of 2. And so that's where the square root of 2 is coming from. But still, can we use these 2 squares to form a larger square? And, it's just, remember, let's go back to the problem at hand, or the question at hand. One of the key things it says is without any cutting. And no matter how I stack a square onto another square, we're just going to get rectangles. I can't put it anywhere to get another square. So I'm going to say that this answer is no. However, what if cutting was allowed? If cutting was allowed, this problem would be possible. If we cut each of these squares in half, then we would have 4 triangles. We would have 4 triangles that have that are 1 by 1 by square root 2. And if we kind of put them together like this, so this is our triangle. It has side length 1, 1, and square root 2. It is half of this square over here. You know, I can use 4 of these triangles to kind of form this what they were asking me to form. Here, if cutting was allowed, you can see that we can form this square. However, cutting is not allowed, so this answer must be no. Great work. Last problem. Can 4 right isosceles triangles with side length 1, 1, and square root 2, and a square of 1 and 1 square of side length square root 2, make 1 square of side length 2? Well, look at that. We kind of just did this in the previous problem. The only difference is we used, what did we do? We used just these triangles to make a square of side length square root 2. Now we have an extra square that's already square root, which is this square, and we want to make a side length of 2. So what can we do? Well, let's just throw these triangles on top. And here, let me again use the line tool. That's a little bit too wobbly, right? So here we have our 4 triangles filled in. Triangle 1, triangle 2, triangle 3, triangle 4. And it will be 1 square of side length 2. So this problem is yes. Awesome. Great work, guys. I hope this clarified some things for you. This quiz was definitely about shifting shapes and being able to visualize and move the shapes around in space and in your mind. If you have trouble with this, I definitely recommend drawing out the pictures, or even taking a piece of paper, cutting the pieces out, and physically moving them. If you can't imagine it in your head, that is not an issue. Baby steps and you will get there. Thanks so much for watching. Until the next video, take care.